Hey guys, doing 9-4, dividing with remainders today. After today you can say, I can divide whole numbers by one-digit divisors, resulting in quotients with remainders. Now, divisors and quotients, those are some of our vocabulary words that we know of, and they are right here. So, divisor, quotient, we just talked about those. Dividend, so just as a quick reminder, 6 divided by 3 equals 2. 6 is the dividend, 3 is the divisor, 2 is the quotient. Today we have a new vocabulary word, remainder. Remainder we're going to talk about in a little bit, but the word to remain, it's what's left over, so the remainder is what is left over. We're going to talk about that here in just a second. Alright, so you know how to estimate the answer to a division problem. Today you will learn what to do when you divide and something is left over. That's that word we just talked about, that remainder. So if we are going to estimate this, we have 63. Well, 63 is close to 64, that compatible number, and I know 64 can be divided by 8. So when I estimate 63 to 64 divided by 8, I get 8. Now, when did you share something equally with other people and had some left over? We could have, any sorts of examples. We could talk about candy. That's supposed to be a candy piece. It's not very good. But if you had that with a bunch of other kids, maybe after Halloween, you could have one kid gets a piece, one kid gets a piece, he gets a piece, she gets a piece, she gets a piece, she gets a piece, she gets a piece, he gets a piece, he gets a piece. Oh wait, we have 2 left over. There's our remainder. There's some left over. You could have any idea with toys. Maybe you have toys that you share with people. Cookies. Maybe you're dividing cookies, or maybe even pieces of pie. After you've cut up a piece of pie, you have to divide equally among those with each other. And you may have some left over, which would be that vocabulary word remainder. Alright, now let's look at this question. Jason has 14 trophies and 4 shelves. He wants to put the same number of trophies on each shelf. How many trophies will be on each shelf? How many trophies will be left over? Well, what part of this question makes us think that we have to divide? Well, he wants to put the same number of trophies on each shelf. If he wants the same number, then that is what we know it has to be division, because we have to divide them into equal groups. That's what division is putting things into equal groups. Now, the question is how many trophies will be on each shelf. That's one question, because there's one question mark. We have another question mark over here. How many trophies will be left over? So we have 2 things we need to answer. How many trophies will be on each shelf, and how many trophies will be left over? So now, let's go ahead and try to solve this problem. I'm going to get this out of the way a little bit so I have more room. Now, as you can see, I've got my trophies here, and I've got my shelves below that. So if I wanted to have 14 trophies, and I need to divide that onto 4 shelves, well, I need to put them onto 4 shelves. So I've got my dividend and my divisor, and I'm just going to take these trophies and put them down here with X's. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 trophies. If I were to do then 13, 14, well, I'm out of trophies. I can't put them on these shelves here, so that wouldn't be even up, because Jason wants to put the same number on each shelf. Well, that's not going to work. So what I have to do is these right here, these trophies here and here, those can't go there, because those are what are left over. So I am going to then take these trophies as my remainder. So how many trophies will be on each shelf? Well, there's 3 on each shelf. And then how many are remaining? We have a remainder of 2. If you want to see it in a different way, you could do 14 divided by the 4 shelves. So you have the 14 trophies divided by the 4 shelves. Well, how many times can 4 go into 14? You could skip count and go 4, 8, 12. That's 3 times. I'm going to keep that in the ones place. 3 times. You could then say that 4 here times 3 gives you 12. Then when you subtract 14 minus 12, you get 2, and then 4 cannot go into 2 because it's too big of a number, so you are left with a remainder of 2. So we come up with the same answer, and then even the same answer over here. Here's another question we have. Suppose Jason decides to place his 14 trophies on 5 shelves. If he wants to put the same number of trophies on each shelf, how many trophies can he put on each shelf? I'll give you a few seconds here to pause the video so you can work this problem out. Again, we have a classic division problem where we've got 14 trophies on 5 shelves, so that's 5 piles. Again, you could do 14 divided by 5, and then how many times can 5 go into 14? Well, you could skip count and say 5, 10. That's 2 because 5 times 2 is 10. You subtract 14 minus 10, come up with 4. 5 cannot go into 4 because 5 is too big of a number, so you have 2 remainder, and your remainder is this right here, remainder of 4. So your answer is 2 remainder 4. So Jason can put 2 trophies on each shelf, and there are 4 left over. Alright, again we've got our divisor, our dividend, our quotient, and here now we have remainder. So we could say that 7 divided by 2, that would be 3, remainder 1, where 7 is the dividend, 2 is the divisor, 3 is the quotient, and remainder is 1. Here you can extend if you'd like. How can you work backward to check your answer to 14 divided by 5? You can go ahead and pause the video and think about it for just a minute. And now here we have our answer of 14 divided by 5 is 2 remainder 4. Now how can you work backwards? What you can do is you can ask yourself, well, working backwards, 2 times 5 would give me what? That gives me 10. And then if I add my remainder here of 4, so 10 plus 4 gives me my 14, gives me my dividend. So you can do your quotient of 2 times your divisor 5, 2 times 5 is 10, plus remainder 4 is 14. If you get this same answer here, then you are good to go. You've just worked backwards to check your work.